All right, so let's look at 2.4 zeros and polynomial functions. The objective is that you'll be able to find real zeros of polynomial functions. So today we're going to look at Descartes' rule of sign. And if you're wondering about Descartes, you'll hear about him when you take philosophy in college. So I think most majors require philosophy. Um, he's the one that said that famous line, "I think, therefore I am." So he's a philosopher and a mathematician. Um, yeah, and he's also the one that came up with the Cartesian plane. So the graphing, yeah, the coordinate plane. So he's the one that came up with that as well. That's what it's named after. Yeah, so Descartes' rule of signs. It's pretty cool. It says if f of x equals that is a polynomial function with real coefficients, then the number of positive real zeros of f is equal to the number of variations of signs of f of x or less than that number by some even number, and the number of negative real zeros of f is the same as the number of variations in sign of f of negative x or less than that number by some even number. All right. So basically we have the number of positive real zeros. Okay. So you just want to look at the basic function. And then if you have like 5x cubed minus 7x squared minus 3x plus 4. All right. So here you just want to look at the different signs. So, and look at the changes. So here it's positive, negative, negative, positive. Okay. So when do the signs change? How many times does it change? Changes once. And this one, it doesn't change. Negative to negative, so that's the same. But then we have a negative to a positive. So this one changes. So how many changes do we get? We get 2. Okay. So it could have 2. Um, so the number of positive real zeros, okay, is equal to 2 or 0. So 2, and then you always go down by 2. So 2 minus 2, 0. So like if you had 6 changes, okay, if there were 6 changes, then you go down by 2s. So it could either be 6 positive real zeros, 4 positive real zeros, 2 positive real zeros, or 0 positive real zeros. All right. And likewise, if it was an odd number, same thing. 5, so go by 2s. You can have 3 or 1. Now, for the negative real zeros, you want to look at f of negative x. All right, so if we use that same one, right? So the sign changes whenever you have an odd exponent. So here this is going to become negative 5x cubed. This one is an even exponent, so the sign doesn't change. So it stays negative 7x squared. This one, because you have a 1, exponent is 1, it does change, it's odd. So it becomes positive 3x. And then that 4 is a constant, so that doesn't change at all. And here we have just 1. So you have a negative, negative, positive, and a positive. So how many times does it change? Just once. There's going to be 1, or that's it. Just 1. 1 negative real zero. All right, and that's what Descartes' rule of sign says. Let's put this in the notes. All right, so here, let's look at this one. I have us doing 30. Let's try 27. Yeah, that's a good. That's what you can check in the back. So try 27. I'll do 30. All right. So I'm going to write it down first. G of x equals 4x to the fifth plus 3x to the fourth plus 9x cubed minus 8x squared plus 16x minus 24. Now it should be in standard form. Standard form is descending order, right? And it has to be, yeah, it has to have consecutive numbers 5, 4, 3, 2, 1, 0. So it looks good. All right, so let's look at those signs. We have a positive 4x to the fifth, positive, positive, negative, positive, negative. All right, so how many times does it change? Positive, positive, positive. Nope. But positive to a negative, that's a change. And then goes from negative to a positive. There's another change. You don't need to write change. I don't know why I do. And then we have positive to negative. So there's another change. So this one, we can have positive zeros. It's going to be 3, or go down by 2's, or 1. All right, now we're going to look at the negatives. So here we go. So for the negatives, we want to look at g of negative x. Okay, and this one I'm going to write. So it might take a while. So I'm going to replace all my x's with a negative x. Da, da, dun, dun, dun. Dun, 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 dun. Yeah, just taking a while. And there we go. So now let's change all those. So remember, whenever you have an odd exponent and a negative, okay, that means it's going to be negative. Negative x with with an even exponent means it's going to be positive. The reason why is because you have a negative times a negative, like a negative x times a negative x. Let's see, there's 2. It's going to be positive because you have 2 x's, I mean 2 positives there. Okay, whenever you have an even amount of positives, it's whenever you have an even amount of negatives, it's positive. So there you go. So this is going to be negative 4x to the fifth. So that means you change it. If it's negative, you change. Positive, don't change. There you go. And because it's a even, we don't change that. It stays positive 3x to the fourth. Oh, let's move this down a little bit. I'm sorry, I didn't realize I was writing on the same line. What in the world is that? Grab the wrong one. That was weird. All right. And then we have an odd one, 3. So change a sign. This is even, so that doesn't change sign. So it stays negative 8x squared. And this is odd exponent, so it does change sign, becomes a negative 16x minus 24. All right, so let's look at the changes. Change, positive to negative to positive. And another change. So we got two changes. So this one, we have 2, 4, 0. And, and that's it. All right. So try 27. Find the number of positive zeros and the number of negative zeros. We put this on the notes. And who do we have here? René Descartes. So this is René Descartes. Yeah, there you go. So when using Descartes' rule of signs, the number of real zeros indicated includes any repeated zeros. Therefore, a zero with multiplicity m should be counted as m zeros. All right, so again, if you had x minus 3 squared times x plus 7, all right, there you have 3 is there, not once, but twice. You just don't write it twice, okay? So you just write it once, but then it's actually there twice because it has a multiplicity of 2. All right. So that brings us to the fundamental theorem of algebra. You know it's important because it says fundamental theorem of algebra. And what is it? It says a polynomial function of degree n, where n is greater than 0, has at least one zero, real or imaginary. All right. It can be a real number or it could have an I. It could be imaginary in the complex number system. So we're looking at the complex number system. That means real and imaginary. Real number, it could be complex numbers. Okay. It says a polynomial, the corollary is a polynomial function of degree n has exactly n zeros, including repeated zeros in the complex number system. So if we had f of x equals 7x to the fifth minus 4x there plus 9x squared minus 1. All right. So our degree, our biggest exponent, okay, that's our n. And that tells us how many zeros we're going to have, real or unreal, imaginary. So that tells us we have 5 zeros. All right. So it crosses the x-axis 5 times, not just um, in the real sense, but also imaginary sense. So it could not be crossing, but imaginarily it's crossing. So there's some really cool videos on YouTube showing the graphs of imaginary numbers. So definitely recommend that. And we have linear factorization theorem. All right. If f of x is a polynomial function of degree n is greater than 0, then f has exactly n linear factors. Okay. So just like before, it has that many zeros. Okay. And then we have this conjugate rule theorem. Now, this is one that you saw in Algebra 2. Remember where you had, remember where you had those radicals? 1 over square root of 3 plus 1. I don't know if you remember that. But in order to solve this, because we can't have a square root, a radical in the denominator, you have to multiply the top and the bottom, the numerator and denominator, by that radical, the whole thing, but not plus, minus, because that is the conjugate. Okay, conjugates, one same number, same two numbers, different sign, right? Just like x plus 7 and x minus 7. Same numbers, different sign. All right, there you go. And there you end up with square root of 3 minus 1 over 2, if you're wondering. All right, so let's do that. Oh, so the conjugate root theorem, it says when a polynomial equation in one variable with real coefficients has a root of the form a plus bi, it's a complex number, a number plus bi. Okay, so 5 plus 7i, something like that, or 3 minus 4i, could be like that also. Then its complex conjugate, a minus bi, is also a root. Okay, so that means 3 plus 4i is also a root, or 5 minus 7i is also a root. The conjugates. If you're wondering, huh, what are you talking about? We're going to look at some right now, so don't worry. All right. Now here it says, write a polynomial function of least degree. Now it says least degree because the smallest possible given all of these. Okay. With real coefficients in standard form that has the given zeros. All right. So if you look at 32, let's move this one. So we have some space. Some space. Some space. Some space. All right. So I'm going to do 39. Why? So why don't you do 34? Oh, no, do 35 so you can check the back. All right. I'll do 39, but let me do 32 so you can see what it regularly looks like. Okay, so these are our zeros. Okay, so we want to put these in kind of binomial form. So factored form. So we have x minus 3, x plus 4, x minus 6, and x plus 1. Notice I'm changing all those signs. Okay, when you put it in those binomial forms. the factored form. All right, and then you want to multiply it. So it's a lot of work. So this one you just need to focus on two at a time. Or you could do, yeah. So x times x, and then x times 4, negative 3 times x, and then negative 3 times 4. So here we're going to get x squared plus 4x minus 3x minus 12. And that gives us x squared plus x minus 12. And I'm going to multiply x minus 6 and x plus 1 also. So x times x plus 1, x times 1, negative 6 times x, and negative 6 times 1. So we have x squared plus x minus 6x minus 6. And simplify x squared minus 5x minus 6. And now we can multiply these trinomials. So same thing. You just want to multiply each of these by each of those terms. So we have x to the fourth, x squared times x to the negative 5x is negative 5x cubed. And x squared times negative 6 is negative 6x squared. And x times x squared is x cubed. X times negative 5x is negative 5x squared. And then x times negative 6, negative 6x. And then last but not least, negative 12 times all those. Negative 12x squared, positive 60x plus 72. And then combine like terms. You got 1x to the fourth. We have we have an x 5x to the third plus 1x to the third. Going to be negative 4x cubed. All right, we're done with those. Now let's look at the squares. Negative 6 minus 5 is negative 11. Minus 12 is negative 33. X squared. And then the x is negative 6x plus 60. That is 16. Okay. So we have 54x and plus that 72. And that's it. Oh, don't forget f of x. All right, so that's 32, but let me show you one with a complex number. That's the one that has the conjugates. I got 7 minutes. Can I do it? I don't know. Let's see. We'll try. All right, so let's do 39. So we have square root of 6, negative square root of 6, and 3 minus 4i. All right, so write these in factored form. X minus 6, remember you're changing the signs. X plus square root of 6, x plus 3 minus 4i. I'm going to put this in parentheses. And oh, sorry, not plus, minus, because it's x minus c. All right, and those are our c's. Minus 3 minus 4i. and then switch the sign. So x minus 3 plus 4i. So that's our conjugate, because it has a plus instead of a minus. Okay, now this one we have to simplify first. It'll be easier. So let's do that. Same, same, not same. So we're going to distribute that negative. We get negative 3 plus 4i. Distribute that negative. We get x minus 3 minus 4i. All right. Now I'm going to do the x minus 3 plus 4i times x minus 3 minus 4i over here. So x times x times negative 3, x times negative 4i. So I have x squared minus 3x minus 4ix. And negative 3 times x, negative 3 times negative 3, negative 3 times negative 4. So negative 3x, negative 3 times negative 3 is positive 9. Negative 3 times negative 4i is plus 12i. And last but not least, the 4i. So 4i times x is plus 4ix. 4i times negative 3 is negative 12i. And 4i times negative 4i is going to give us negative 16i squared. Ooh, that's a lot. All right. Now we want to combine like terms, but remember this is I squared is the same as negative 1. So this is negative 16 times negative 1. It's going to give us positive 16. Okay. So let's combine like terms. We have 1x squared. All right. Let's do the x's. We got a 3x. This one has an I, so let's not do that. Negative 3x minus 3x, negative 6x, and that's it. So minus 6x. And now let's do the ones with the ix's. We have negative 4ix plus 4ix. Oh, they cancel each other out. Yeah, which they always will. Okay, unless you did it wrong. Yeah, conjugates should cancel them out. And here, um, our constants, we have 9 plus 16. So that's going to give us 25. And then 12i minus 12i cancels out, which they should. And we get x squared minus 6x plus 25. There you go. Now let's do the same thing with the x minus square root of 6 and the x plus square root of 6. All right. And if you're looking at this, you're probably wondering, hey, Mr. T, it's the same except opposite signs. One is minus, one is plus, one is plus, one is minus. It's a difference of squares. Actually, it's a so here it's going to be whenever you have a minus b times a plus b, All right, that's going to be equal to a squared plus, sorry, a squared minus b squared. So this one is going to give us x squared. That's our a, and then our b is square root of 6. So x squared minus square root of 6 squared, which is x squared minus 6. These kids know. So there we have x squared minus 6 times x squared minus 6x plus 25. And then multiply 2. So you get x to the fourth. X squared minus 6x cubed. X squared times 25 plus 25x squared. And negative 6 times x squared. Negative 6x squared. Negative 6 times negative 6x plus 36x. Negative 6 times 25 is going to give us negative 150. 6 quarters makes $1.50. All right, and combine like terms. Yeah, x to the fourth. And x cubed. That's it? Okay. So negative 6x cubed. And negative 6x squared. Oh, sorry, this should be a squared. That should be a 25x squared. So 25x squared minus 6x squared is going to give us 19 squared. And then 36x minus 150. And that, as they say, is that. Oof. That's it.